The executor framework is more like a teamwork. You have a team of workers, you have a team of threads in the thread pool. Now, if you look at this, couple of things to show. Firstly, executor service extends executor, like we said. So executor is the base interface, which has this execute method, the runnable task it is taking. It is up to the restaurant management to decide how they will assign the order to which chef. Now, there must be some limitations with this, right? The code that we have written, there must be some limitation. What is the number one limitation? Manual creation of thread. Hello and welcome everyone to my channel Code with Ease by Varsha. So we have been doing coding questions related to threads. We recently started a series on that. Today we are going to learn about executor framework and thread pool, but not in a theoretical way. We don't want to make it very boring. Of course, we want to cover the brief overview of what executor framework is, what is executor service, why do we use thread pools. But with that, we're also going to solve a very interesting question, a very real worldish kind of question, actually implement our executor framework, the executor service, and also we're going to see how does thread pool come into the picture. So let's go to the question. So this is the question that we have, concurrent file reader program. It says that we are tasked for developing a generic concurrent file reader program in which that can take data from multiple text files concurrently using Java's thread pool and the executor framework. So these are the following criteria that we have. It should be able to read from multiple text files simultaneously. The program should process and print each data entry. Each data entry that gets printed should be prefixed with the name of the thread that processed it. And we have to utilize executor service for managing the threads. And finally, we have to provide a mechanism to gracefully shut down all the threads that have been read. So that's it. I have 3 files. I will manually create 3 threads and assign each thread to each log file. So now let's see the code for this. So if you look at the code over here, the concurrent file reader example, here I have taken 2 different file paths. Each file path is containing logs file. We'll see the content of the logs file in a while. So what I have done is, here there's a read file method, a standard read file method where buffered reader and then going through every read line, and then we are printing the name of the thread using this static method thread.currentThread.getName reads line, and then we are printing which line is being read of that particular file path. So over here, if you see two threads we have created. One thread is the task of reading file path 1, and file 2 thread is going to read the file 2 path. So these are the 2 tasks which is being assigned to 2 threads. The threads are started. We wait for them to complete because it is a loop, because it has to run through every line of the file, and then finally we just do a try catch and done. Within this read file method only, we are printing out the content. So if we run this, so this is what the logs are. You're seeing the name of the thread and the logs, whatever is logs are there. So thread 1 is reading line 1 of sample logs 2, whereas thread 0 is reading the application started, the logs of the other file. So thread 1 we can see continuously is reading different lines of the sample logs 2 file. So this is how it is trying to process every line, printing the name of the thread and processing. Now there must be some limitations with this, right? The code that we have written, there must be some limitation. What is the number one limitation? Manual creation of thread. New thread like this, I have to keep on creating the thread. For every processing that I am doing, I have to assign a task to every thread. Manual creation of thread. I don't know how many files I have to read. Now over here we have hard coded the file path. It can be that there is a location like a AWS S3 location which has n number of files, 100,000, 5,000, we don't know. All we need to do is we have to iterate through that S3 location and then read all the logs file that is over there in that S3 location and do our processing. In that case, how are we going to understand how many threads we need? That is the point, that manual creation of the thread. Another point is I only have to start the thread. I only have to do the join, like I have to do the waiting. So all the life cycle management of the thread is being handled by me, the developer. I have to create the thread, start the thread, wait for it to complete, like do the graceful shutdown, everything. I am only responsible. So my work is not just to write the processing logic of reading the file or whatever processing I'm doing with each file. My also worry is to manage the life cycle of the thread. So the developer is not having a separation of concern. He has to also worry about the business logic as well as about the thread's life cycle. So this is the biggest reason why executor framework came into picture whenever we have to do concurrent processing of files. So now let's see in detail what is executor framework, why it is used, how is it related to thread pool and all of that. Cool. So now let's talk about the executor framework, and then we will see how can we modify the code that we have seen just now using the executor frameworks, classes, and the thread pools. So what is executor framework? It is a component of Java's java.util.concurrent package, which helps in the management of thread execution in concurrent programming. So this was our main headache, right? The life cycle management of the thread we don't want to do. We don't want the developer to manage the life cycle, creating the thread, starting the thread, waiting for it to end, then shutting down. All of that I don't want to manage. So Executor framework has a set of classes and libraries that does this. Next is, why do we need this? A very simple layman example can be, if it's like a teamwork that you're doing, a team of cooks, you want to prepare different dishes. So like I said, there's an S3 location, AWS S3 location has 1K files, or it can be even more in real production scenarios. If there are 1K files, so you have different dishes and you want to process all these 1K files simultaneously at the same time. So you need the worker threads. So you have to assign these to your worker threads. We'll come to the worker threads and thread pool concept in a bit. So you need to assign this so that the multiple tasks can be handled together, and then it is not the headache of the developer to assign each file to each worker thread. I will have a set number of worker threads. Let's say I have 1K files and I have 10 worker threads. So how these 10 worker threads are going to process these 1000 files, that is not the headache of the developer. That is something which the Executor framework is going to deal with. My work is I assign the work to 10 threads and I tell how much work I have. Similar example of a restaurant, that restaurants keep on getting so many orders, but you have a fixed number of chefs in the kitchen. You have 5 chef or 10 chef, but you are getting incoming orders. It is up to the restaurant management to decide how they will assign the order to which chef, how to get the work done in the most optimized manner. It is not the worry of the client. So the benefits of the Executor framework are efficient thread management. We have seen this, we have understand the point that why, and of course the simplified thread lifecycle management. Now to support this framework also we need certain classes. So we have certain components. So what are the components? The core component is, first is Executor interface. This is the main interface which represents an object capable of executing task. So task, right? What is the task in our case? To process the file. So this is the task that we have. So Executor framework is representing, this is the representation of the task. It contains a single method which is called void execute. And this is the method which we are also going to use. And this takes a runnable task. So we know that whenever we are creating threads, we usually use the runnable interface. So the thread, whatever we are creating, we are going to submit it via this method. So this is one component. Another component is Executor service interface, which is a sub interface. Sub interface means, suppose you have Executor interface over here, which is being extended by Executor service. When we go to the IDE, we'll also see the classes one by one. We'll examine all the classes one by one. So this is the interface, the base interface, and this is being extended by Executor service. This provides a higher level API for managing thread execution. So as we can see, Executor interface is only having one method, just to execute. But apart from executing a task, you also have a bunch of different tasks to execute. Like I said, shutdown. The management is not just to execute a task, you also have to take care of other activities. So this Executor service provides many such other APIs to manage the thread execution, like task submission, termination, and many other things. The next component is important. It is the thread pool executor class. We will see how it is being used. So thread pool executor class is the most commonly used implementation. So now Executor interface, we understood it is extending the Executor interface. Now we know that any interface has to be implemented by any concrete class. The thread pool executor does that. It actually implements the above Executor service, and then so this is the most commonly used implementation of Executor service. It implements this. Now this class manages a pool of worker threads. Remember the analogy of worker threads or the chefs in the restaurant that we were talking about. So this class exactly helps to manage the pool of worker threads for executing the task. So far Executor and Executor service were giving me the higher level overview, or like the higher level APIs to manage the end-to-end life cycle of the thread. But when I say to manage the pool of threads, from where I will say that I have 1K files to process, like I said, and I want only 10 threads to be utilized, 10 worker threads to be there. So who is going to manage that? So thread pool executor does that. How? It helps us by allowing some customization of the thread pool size, thread eviction policies. All of that is not the scope of this video. We are not going to talk about thread pool implementation or the thread pool optimization, all of that. We can take it up in a different video because that it will make this video very lengthy. So that is what. So these are the core components. Apart from this, there is also a very important class which is called the Executors class. And this is similar to thread pool executor class. This is also very important because this is the most commonly used class, because it's the most commonly used utility class, which has a couple of factory methods. A very popular one is single-threaded executor, which we'll use. This provides these factory methods to create different types of executor service instances. So this is the interface we told. And thread pool executor class is the most common implementation we told. Now, we also have different types of implementation of executor service. So this executor class will provide the factory method so that you don't have to do new and then do the class name every time. You just have to do executors dot whichever class you want to call. The next thing is the life cycle. Like I said, the life cycle of a thread. First is we submit a task. So first, the task is submitted to the executor service. Executor service. Now there is a catch over here, and this is a very common interview question, that the difference between executor and executor service. Executor interface was only having one method called execute, and that could only take runnable instance. There is one more interface called callable. Now callable and runnable also has a different. Runnable does not return anything. Callable returns. There's a return value associated. Now executor interface only had this execute method. Executor service, since it has more number of methods, as you will see, it has another method called submit. So which can take runnable, callable also, like the type of objects, whatever type of thread you want to call, whether you want the thread to return something or you don't want it to return. So first is submit the task. So next is task queuing. Tasks are stored in a queue. Now, like I said, there are 1K files. Now all the, these are, you can imagine these are 1K tasks that you have, and you have only 10 threads. Until a thread is available, your task will have to be in a waiting state. The next point is thread execution. This is the main part, right? Where it actually invokes the run method, like we say. So now worker threads will actually do the execution of the task from the queue. So it will take the task from the queue and start executing them. And finally termination. So broadly we have submit, queuing of the task, execution, and the termination. So all of these constitute the life cycle of the thread, which we as a developer don't have to manage. So this is about the very brief overview of executor framework, executor service. I've tried to cover as many points as I could on this. Now let's talk about thread pools. Okay, so far we have discussed about why the executor framework is needed, how it can help us in simplifying the lifecycle management of thread, and the developer doesn't have to worry about the creation of threads and all. So we understood how it helps. The answer to that how is thread pool. So we mentioned this term called worker threads many times. So thread pool, what is a thread pool? It is a collection of pre-initialized thread of the worker threads which are ready to execute the task. So instead of creating a new thread for every task, you just borrow one from the pool. So you have a pool of tasks, just borrow one from the pool, do the task, and then put it back. It will come back to the queue again, return it back to the pool. Now, the analogy which we were given. So if you have a team of workers, so it is the executor framework is more like a teamwork. You have a team of workers, you have a team of threads in the thread pool who are ready to serve the orders. So I don't want to hire a new chef whenever there's a new order coming in or new customer walking in. I have a team of 10 chefs fixed in my restaurant. No matter I have lesser orders or more orders, I will have to assign that task to the orders to the chef at the restaurant, and they are only going to process it. They will take the order, prepare it, and then they'll just keep on waiting. So this is the same exact concept of the thread pool. So you pull a task from the pool, make sure that the thread works, complete the task, whatever is given, and then go back to the pool. So you already have a team of threads who are ready to serve whatever business logic you want to process. Now, why do we need it if we have to talk about it? Threads are already created. There's no overhead of thread creation. So it was not only about the developer who has to create the thread. When a developer is trying to manually create the thread, there's also some time it takes in creating the thread by the traditional method of how we are creating. Now, when there's executor framework which comes in the scene, it has its own ways to create in bulk, because we mentioned about the executor class, right, where it provides different factory classes, factory methods to initialize different instances, whether we want a single thread or whether we want like 3 threads only, like a fixed number of threads, or whether we want a cached thread pool. So there are many different types. So there is no overhead of the thread creation time. Limits the active threads, okay, number of active threads. So now see this, when I am creating 3 manual threads, and it is possible that all 3 are not needed only, so they are kept idle. So it is an estimate which I have to do it on my own, that I will have these many tasks and I will create 50 threads. Very much possible in the 50 threads, out of that a large percentage of 50 threads is sitting idle. I don't have to I don't have the capacity, it is beyond my capacity to make sure that all the threads are being utilized, are utilizing the CPU all the time. So number of active threads is limited, and this avoids the resource exhaustion. Again, simplifying thread lifecycle management, we already told creation, execution, and termination. And it can adapt to changing workload by dynamically resizing the pool. So this is also an important point. Now, this is beyond the work of the developer, that if in traditional cases we could not have done the dynamic resizing, but when we use thread pool, that is also possible now. The use case of thread pool is a variety of them: web server, parallel processing, task scheduling in ideal production scenario, many different processes that you will have. But today's example that we are doing is a very basic fundamental example that we have taken, the file reading. Now what we need to do is, let's try to refactor the code that we have written for this, the file reading, and try to incorporate executor service into that. So this is the code that we have seen earlier here, where we were trying to hard code the file. So I have taken one more logs file. So I have 3 logs file now. So let me refactor this code. So I'll delete all of this. What I'll do is, I'll take a string array of all the file paths. So here I have an array of this. Now in real world, again, this will not be hard coded thing for you. It will be like you have to iterate through a certain location and read the files from there using a for loop or for each loop, whatever. Now the fun part, how can we use executor framework? Now in this, I'm not going to do new thread equal to new thread, all of that. Now what I'm going to do is, I'm going to use executor service and my executor service, use the factory, the static, use this utility class, and then we can see that these are the bunch of different factory methods which we were talking of. Fixed thread pool, which will take a fixed number of threads only. New single thread executor, there will be only one thread which is going to do the back and forth. New cached thread pool, new scheduled thread pool, new work stealing pool. These are different implementations. So if I take new fixed thread pool, and let's say I have 3 tasks, 3 files to be executed, and I will do it only by using 2 threads. I am not going to manually create 3 threads. Now if you look at this, couple of things to show. Firstly, executor service extends executor, like we said. So executor is the base interface which has this execute method, the runnable task it is taking. Executor service, on the other hand, has so many different methods. It has shutdown, is terminated, the submit task, which we were saying, it takes a callable task also, it takes a runnable task also. So this is about the executor service. Now if you see this particular method, new fixed thread pool, over here, this is returning a thread pool executor. Now what is thread pool executor? Like we said, the implementation of executor service. So again, if I go into this is the thread pool executor class. See this, thread pool executor extends the abstract and executor service, which in turn is trying to implement executor service only. So thread pool executor is also a concrete class of the executor service. And when I call new fixed thread pools, it takes in, it returns a constructor of thread pool executor, where all of these are the values that we pass into the parameters that we pass to the constructor, where it takes in a fixed number of thread. And here is the entire Java doc, which you guys can read to understand what it is. It reuses a fixed number of thread, reuses the fixed number of chefs in the restaurant. So let's go back to the code. Now I have 2 threads. Now what I need to do? Now I have to run a for loop, where I have to say that string file path over my file paths, and then I'll call the executor service. Now notice here I'm not doing new thread, I'm not doing start thread, I'm just going to do this executor. I could have done execute also, or I can do a runnable also. If I do a submit, it returns a future. Future I'm not talking about in this. So let's try to use execute. Execute is returning a void, okay, and submit will return a future if you want to capture something. Anyway, so I'll use execute. Over here, what I'm going to do, I'll just use a lambda expression, and over here I'm just going to say whatever the work is. So my read file is the work, and I'm just going to pass in my file path. So my work is assigned, I used lambda expression, and I gave executor service the entire responsibility of executing each file from this location of the file path. It will execute each file from this, and it will make sure whatever fixed thread pool I have given, from within that only it is trying to rotate, like do the back and forth of context switching of work. That's it. It is so simple. We wrote this, how much thread we need, we gave a location, and we asked executor service to deal with the entire work. Another important work that we ourselves have to do is, we just have to ask it to be shut down. So I just call executor.shutdown. I am not trying to do that thread.join and waiting for it to complete. Now let's try to run this. Okay, so what we have done is, here I also added the file path, I've added the thread which is printing and the line. So see, sample logs 1 is the location, pool 1 thread 1, the notation is different. Earlier we were seeing thread 0, thread 1, thread 2. This is a pool for this, from this pool 1, from this particular pools, thread 1 and thread 2. There will be only 2 threads. Within that it is only going to rotate. So sample logs 1 is being read by thread 1, sample logs 2 is being read by thread 2. Again sample logs 1 is being read by thread 1, sample logs 2 is being read by thread 2. So in the picture, we don't have sample logs 3 in the picture yet. Once the reading is done, then sample logs 3 is being picked up by thread 2. So we see that we didn't require a different thread. with 2 threads only we could process this, and the program has ended. So we didn't have to manage anything about the threads. We had 2 threads, we have 3 tasks. Over here you could also have 10 different files to read. The swapping, the context switch between the file, reading of the file would have been handled by the threads only. So this is how we can use executor service and thread pool to solve this kind of concurrent file reading problem, or any kind of problem which requires us to do bunch of different tasks and we have limited resources or limited number of threads that we can use. So thank you so much for watching. Hope you guys have got some value from this video. Thank you so much. See you guys in the next video.